In this lesson, we are going to use line of best fit to forecast or predict the value for one of the variables in our relationship. The question is the following. First, the graph of playtime for some Toronto Maple Leaf forwards is given down below. First, we have to find the equation of line of best fit. The line of best fit is already drawn for us, so we don't worry about deciding how to draw the line of best fit. And part 2 of the question says, using the equation found in part A, estimate number of shifts per game if 99 games are played. Now, usually, for instance, for 99 games, you look at the graph, you find where exactly is 99, and then you either interpolate or extrapolate the value. But if you look here, 99 is somewhere outside the graph, which is here, which we have no access to the line of best fit. So this is why we need to find the equation of line of best fit. Now, to find the equation of line of best fit, we use the general equation of a line, which is y is equal to mx plus b, where m is the slope, b is the y-intercept. Now, the y-intercept is this point that I have shown on the graph, where the line crosses the y-axis. But again, the point is approximate. We cannot for sure say if it's 5 or 6 or 2 or 3. And slope is the rise over run. Now, another equation for slope, if you remember from grade 9, is m is equal to y2 minus y1 over x2 minus x1. These y2 and x2 and y1, x1 are the coordinates of 2 points on the graph. So the first thing I'm going to do is that I'm going to pick 2 points on the graph. The points that I'm going to pick are the points which are going to be the cross of the grid lines, or very close to the intersection of the grid lines. So I'm going to pick this point, which I'm circling here, and also this point, which I'm circling, because these are on the graph, on the line, and they are almost at the intersection of the grid lines. So this point, the coordinate of this point, as you can see from the graph, the x value is 30 and the y value is 10. So this guy is 30, 10. The next one, which is this one, as you can see, the x value is 10 and the y value is 5. So I'm going to write 10 and 5. Now I'm going to go ahead and use this formula to find the slope. So I'm going to say the slope, m, is equal to y2. Now, I can pick any of these points as point 2 and the other one as point 1. Let's say I pick this one as point 1 and this one as point 2. So y2 is 10 minus y1 is 5 divided by x2, which is 30, minus x1, which is 10. So the answer becomes 10 minus 5 is 5 divided by 30 minus 10 is 20, and 5 over 20 is 0.25. So I know that my equation becomes 0.25 x plus b. B is the y-intercept. Again, b is this guy. And I have no idea what exactly the value of b is. But the best way to do it is I'm going to pick another point on the line of best fit, which is at the intersection of the grid lines, or very close to intersection of the grid lines, and then I'm going to sub it back in this equation and solve for B. Now, if you look at the line, probably the best point that I can pick is at this intersection here, which is not exactly on the line, but it's very close. So I'm going to pick this point, which is going to be 80 on the x, and the y value is going to be 25. So x is 80 and y is 25. So I'm going to put it back in this equation and solve for B. So I'm going to say 25, which is y, is equal to 0.25 times x, which is 80, plus B. If you go ahead and solve this problem, you are going to find B is equal to it's going to be equal to 5. So B is equal to 5. So I'm going to say that the equation becomes 0.25x plus 5. That's the equation representing this line. Now, if we go back to part B, it says if we play 99 games, what is the number of shifts per game? This means that x is 99. So I'm going to replace x equal to 99 and evaluate y. So I'm going to say y becomes 0.25 times 99 plus 5, which is equal to about 30. This means that if you play 99 games, there is almost 30 shifts per game.